Hello, everyone. So thank you very much for joining this webinar. Our webinar today is on the K11 Musea, Sculpting a New Typology of Facade. We're doing this at a slightly different time today because of where the project is. So we know in our audience, we have people from Hong Kong and Asia, but also Europe as well and further afield. So it's nice to sort of reflect the international interests of our practice and also construction. So my name is Yanchi. I lead EOC's Hong Kong office. Just a little bit of housekeeping. So during the session, please feel free to ask any questions. So there should be a sidebar on your right-hand side of your screen. So just type in some questions if you have it, and we'll come to those towards the end of the session. So today I'm very delighted to introduce to you James O'Callaghan and our guest of honor, Jeff Tung. So Jeff Tung is a Senior Project Director of the Project Management Department at New World Development. He's responsible for leading projects across Hong Kong, China, and Southeast Asia. And Jeff recently completed the remodeling of the New World Centre into Victoria Dockside and the rejuvenation of the Tsim Sha Tsui waterfront in Hong Kong. And Jeff is a Hong Kong registered architect and a fellow of the Hong Kong Institution of Architects. And so James co-founded Eckersley O'Callaghan in 2004. James is a structural and facade engineer, and amongst his many interests and expertise, James is renowned as a world expert in glass structures. So under James, we've engineered some of the world's foremost innovative glass structures. And in recognition of his contribution to the profession, James was awarded the Institution of Structural Engineers Gold Medal in 2019. So welcome. Thank you for joining us. So let's start with Jeff. So hi, Jeff. So could you tell us a little bit about Victoria Dockside, where these tubes can be found, and in particular how the project came about and what was the sort of genesis of the design concept?
Right. Well, good day, everyone. My name is Jeff Tung. I think Yanchi has given you a brief summary of what I have been doing for the last 10 years. Let me tell you where is Victoria Dockside in case you guys are not residing in Hong Kong. So Victoria Dockside is a 3 million square foot redevelopment project at the tip of the Kowloon Peninsula. If you refer to your top left-hand corner, you will see a map of Hong Kong and Kowloon. And this rectangle, dotted rectangle, is the location of Victoria Dockside. Originally, it was a dockyard. It was called a hose wharf in the old days, before New World Development bought the site. We bought it in 1970s, and we turned that into a New World Center at that time, which is the before the remodeling. The New World Center is like the bottom right-hand corner image that you see right now. At that time, New World Center, when we actually opened New World Center at that time, it was already a very different development project, comprising of hotels, service apartment, offices, shopping mall, and all the entertainment needs that you need for a comprehensive development. But because of the age and all the restrictions that we have, eventually we decided to give it a total new revamp in the late 1990s. And we started work to remodel the New World Center in 2009, and we turned that into Victoria Dockside. Victoria Dockside actually comprised of Rosewood Hotel, which is the high-rise tower you saw at the back, and also K11 Atelier, which is an office component at the lower portion of that tower. We also have K11 Artists, which is the building on top of the podium that you saw with curvy balconies. And we have the K11 Musea at the bottom. K11 Musea is a multicultural and arts integrated retail mall, which occupies actually 1 million square feet. And the Artist is a service apartment hotel one of the major distinctive feature of the development is that you will see a very tall and very wide visual corridor at the center of artists. And Yuanqi and I think the main purpose of these webinar is to introduce the glass tube. I think from this photograph, you will see where the glass tube are located. It's actually located on the 6th floor and 7th floor of K11 Musea. And we use that as part of the visual corridor connecting the harborfront and the Kowloon Peninsula and the rest of the Kowloon Peninsula. The glass tube, the maximum height is actually 9 meters and varies in height. We use this after completion. Actually, we use this space as the K11 Arts and Cultural Center. We have exhibition, we have permanent art exhibits, and we also have temporary exhibition and events being held in this floor. So as you can see, this is only part of some of the images of the artwork we installed on this level. And I think at this time I better hand it to James. Introduce the technical part of the project for us, please.
Thank you, Jeff. Thanks very much, and thank you, Yuanqi, for the introduction. It's great to be here today to talk about this project. I'm very grateful that we've had the opportunity to present K11 in one of our webinars. It's been a really exciting project for us. It's been some time in its making, but like all good things that take that time, it's been a real success. And talking of success, clearly, you know, in order to make a successful project, you need a great team. The project was one of those sort of pivotal projects for EOC that define the character of who we are and what we can achieve when we got the right team in place. A great project needs a great team, and its heart is perhaps more than anything is great leadership and determination from a client to ensure that all the team don't waver and get to the end. And I have to say that certainly in the case of New World Developments, that was certainly the case. It was a long journey, but they were very supportive throughout the project for us all within the design team to ensure that we got there, and it certainly had its challenges. The project is clearly significant in scale, and for the overall development, there are too many people to list in terms of all the collaborators. But so we'll just this particular slide refers mainly to those that were involved within the glass tubes museum project part itself. So first of all was our collaboration. It was actually our first collaboration with the design architect Seele, specifically with Jinglu, an incredibly talented architect with a deep interest in how light and therefore glass, as one of the mediums that can achieve that, can shape and inform space. She's deeply knowledgeable about gallery design and all of which comes with it, and she really brought that to bear with her team on this project in its concept. Like very much all of our projects, and very much at the heart of what we do, we rely very heavily on the makers, the contractors and the fabricators that bring these things to pass, particularly when it comes to innovation, when you're pushing boundaries and developing things that haven't actually been built or even haven't been made at that point. You're very reliant on the creativity of those physically making and physically building it. So a special thanks to seele as the main contractor, or the specialist contractor for the glass tubes, and to Eckersley for all of the efforts, belief and hard work they put into creating what became these glass tubes. A special thanks to Arab as the RSE for helping and supporting us all the way along. They had a big project to manage, and they did all they could to support this part of the project and helping us get in there. And finally to Spears and Major and my friend Keith Bradshaw, who I know is listening, for highlighting the project and making it sing with its team's orchestration of lighting brilliance. So that's very much an important part of what we've ultimately seen. So that's the team, as you can see here, and thanks very much for everybody in that. And I'm going to now talk a little bit about the technical development of how we came to this particular solution as it relates to the building envelope. So this is what we were essentially presented with at the beginning of the project. This is a rendering by the architect, by Seele, that really illustrated the idea that Jeff touched upon in that previous slide of how this corridor linking the development to Hong Kong Island. And it was through this either side of this that you get these museum spaces and gallery spaces that were intended to display the various art, etc., that's been collected, and to be a public space, to be a space in which people can access. So it was also obviously a part of a very larger mixed-use development, which Jeff has touched upon, with a great deal of different uses, and in many ways, in terms of architecture, making this element, creating its own identity in the mix of all the other architecture was important to Sorel and to New World. And so this idea of creating this band at the 6th and 7th floors of light, which highlighted that of the museum space, came to pass. And then it was really this idea about how you can give that texture, how you can give it context and depth. And I think from that, the idea of these glass tubes was initiated. And that's pretty much at the point at which we started to get involved and started to look at ways in which we might actually be able to achieve that with what we knew about glass. So some basic statistics, because we all like a few statistics. There's about 300. There is 308 glass tubes in total. The largest of which are 9 meters. There's a facade area of 2,500 square meters. So it was pretty big, and it was an awful lot of tubes to consider. So it was, in terms of facade area, it was significant. The solution in terms of in terms of what the tube or the glass would be became very important with that respect. And of course, with that much of it, the solution to each one of them being replicated was vital, not only in terms of the quality, but how you solved that. So that's very much where we started out. So a reasonably tall and challenging concept to try and resolve. And I suppose in many ways it's, in particular in this project, it's as much about how we develop the glass as it is about the engineering itself, but certainly the way in which we could achieve this ideal, given that we were somewhat constrained by what was available at the time. So let's just touch upon what was available at the time and what we're trying to achieve. So here we are. We're looking to get 9-meter tall tubes, ideally of a radius of about 400, maybe 500 millimeters. There was some flexibility in the diameter that it could be, but certain technologies such as hot bending and tempering, which I'll touch upon, took us outside of what was reasonable. So what are the options? Well, glass tubes have been around for some time. In fact, the very first glass tubes were in the early 1900s by a process developed by Schott, really for the creation of experimental chemical tubes and for medical purposes, the idea of test tubes essentially, using borosilicate glass being a glass that has a very high tolerance to temperature. Now that process has developed, and of course the chemical industry has developed over over the last 100 years or so, and such that today, or at that point in 2014, the sort of maximum diameter actually of a tube that you could achieve in borosilicate tubes is about 400 millimeters. I've got the radius there, but it's actually the diameter, and the maximum length of about 3 meters. Similarly, if you move to hot bending, which is more sort of and tempering, which is more a traditional way of creating curved glass, that's been developed from the tempering process of heating it up, bending it over through a machine, which then allows the glass to be tempered at the same time. That was giving us that sort of results in, and even today, a sort of minimum radius of around 900 millimeters, meaning we'd need tubes of about 1.8 meters in diameter. Again, a little bit too large for what we were looking for. So forming it, or forming glass and slumping, was one way of looking at it, and that's ultimately what we chose to do, which involves a mold. So just I'll just move on to the next slide. So here, so the sort of the Schott process, or the borosilicate process, is kind of illustrated here, where it's in fact a gravity-drawn idea, and it's still the same today, where your molten glass is elevated within the process and it falls through gravity through a former, and in this instance of a tube, it forms through a sort of circular nozzle, which then creates this drawn tube. Some examples of where that's been successfully used in architecture is Tower Place, Foster & Partners in London, where this facade was successfully supported by these tubes of about 150 millimeters in diameter, bracing a cable net wall. And that was to some extent where we were looking to extend this idea from, as well as other projects such as Casa de Musica by Rem Koolhaas in Porto, which on a much larger scale had got much more large curved pieces. So this was a kind of beginnings of what we were thinking about. So with the idea of the shot tubes, the first challenge that we were faced in looking at that, given that we could live with the 400mm diameter, was how we'd get 3 meters to 9 meters. That wasn't a process that could be made, so it needed to be considered in a different way. And we drew upon a project, one of our projects from 2006, where we had a similar challenge in that glass fins were unable to get greater than 6 meters. So in doing so, we took 6 meters and 4 meter pieces of glass. Again, that was the limit of fabrication at the time. It was the limit of tempering, spliced them together and laminated them together to create a 10 meter piece of glass. Now, at that point, that was a relatively innovative way to achieve that, and it led to a whole journey of much larger format glass, which I've talked about before in one of our webinars. But moving on, we wanted to extrapolate that idea from into tubes. So we looked at saying, well, okay, let's take our 3 meter shot tubes, let's laminate onto that half tubes over the joints, over the hairline joints, and splice it together to make a much larger 9 meter tube. Fairly ambitious idea, but theoretically, structurally, not really particularly an issue. The challenges very much came from the ideas of lamination. So here is one of those 400mm diameter tubes, rather beautiful in themselves, in a circular nature, again at 3 meters long, coming out of its furnace. And this is a kind of illustration of what happens with some of our experimentations when we started to try and laminate them. What happens is that when you put the tube within a tube and you can get the 2 right diameters together, or even 2 half diameters around a tube on that scale, that the shrinkage within the interlayer between the two and the imperfections between the 2 surfaces caused an awful lot of cracking in the process. And we didn't quite get to the point where we were satisfied that making 308 tubes in this nature was not going to yield significant number of failure in the fabrication. So it was relatively quickly written off as being something that we unfortunately couldn't use for this particular application. So we moved on and we were looking at hot bending and tempering. And as I've talked about before, this is essentially takes flat glass and uses the tempering oven to bend the glass itself into various radiuses. And that's something that we, through the work we've done with North Glass, in fact, for Apple in China, developed the process of curving much larger pieces of glass. So here, for example, this project in 2010 was as a result of developing a heat curving tempering oven of up to 18 meters. These panels being 12 meters tall, with a radius of about 5 to 6 meters. The challenge with tempering and thermally tempering glass is the radius. The machines can only bend to a certain diameter, and that wasn't tight enough for us or complete enough for us to be able to get a semicircle. So we were very much faced with the idea of looking more deeply at hot bending and slumping, which is essentially taking the mold that you want to form the glass and then heating the glass over that mold, letting it settle into the mold, and then cooling it at a controlled rate such that it was annealed, leaving you the form. Now, there's challenges with that, a lot of challenges with that, because of the quality of the mold that you use, the rate at which you cool it, and of course, actually in many ways, some of the challenges are actually in the form. It's actually getting that 180-degree half cylinder. So perhaps jumping forward a step beyond where I should have done, what we were looking for at this point was therefore taking half tubes and joining them together to make this whole tube, and finding a way in which we could seal them to create these whole tubes, and then successfully consider how we would maintain that space, which I'll come on to. So these were some of the first examples after lots of prototyping from Precursor in Barcelona. Fantastic glass company, famed for its knowledge in curved glass and its quality. And this project really was a significant step in illustrating their capabilities, I feel. And this was their first of these 9-meter tall glass tubes. Now, what's important is that, the consistency of that radius was really challenging. Getting the mold any joints or any forms in the mold not to be translated through into the glass was very important. So getting that consistent quality, and also bearing in mind that we intended to laminate these half tubes. So that means taking two tubes and nestling them into each other, slightly different radii. In order to do that, it's very important that the surface quality of that glass was consistent, so that the lamination process would be successful. Another really important part of this is the tricky part, or the tricky bit of laminating, or curving, should I say, a 180-degree piece of glass, is that the last 25 to 30 millimeters of the curve, the sort of tangent, no longer remains fully curved, because the way in which glass curves, it uses its own weight to take its to curve it around the mold, and therefore as you get to the end, there isn't any other glass to sort of pull that piece of glass adjacent to the mold itself. So you get a slight flare, and controlling that is super important. Otherwise you end up with not a very a fairly tricky joint between those two half circles as they come together. I have to say that Precursor worked incredibly hard and managed to get that to a virtually imperceptible character of this particular tube. So just some shots of Precursor's facility. Here you can see the flat glass being cut prior to its bending process and its slumping. After it's been slumped through the oven, you can see here these two half tubes nestled one on top of each other, and you can just about see the plastic layer between the two, which is the interlayer, which is before it's then put into the autoclave and heated under pressure in order that the two pieces of glass would bond together. This is the preparation of that. Again, you're getting an idea. This is actually, you can just about see from these are the completed half circles. You can see that just about pick out that these are in fact laminated, and you can just see the edge of the interlayer between them. So this is ultimately the process of making these 308 tubes, and then storing them, managing the logistics of them. And we shouldn't underestimate the challenge of getting all of that glass from Barcelona to Hong Kong successfully on time, without any breakages. Was in itself a significant feat. So I have to say that was a very important part of the process, which we shouldn't gloss over. So just to give you an idea of the scale, here's a plan of the space. It illustrates all of the 308 tubes next to each other, some of which are whole tubes, some of which are half tubes, depending on where they are and what their purpose is. And we can touch upon that shortly, but this gives you an idea of what we were, the basic plan in which we were looking to achieve. And on elevation, it's fairly straightforward what it is, but you can certainly get an idea from this drawing about the repetitiveness of it and the importance of getting the detail right when you have that level of repetition. You'll also notice that there are openings, and of course with any glass facade, it's all relatively nice and pure until such a point you need to put a door through it. But of course, we always need doors to go through facades mainly. So that's where a lot of the engineering challenge comes from, because you want to be in a place where that door or the aperture doesn't significantly distract from the idea and the purity of the facade that you're developing. So from our perspective, despite the fact that it's a very practical, pragmatic reason, we see a lot of our engineering expertise goes into resolving these kind of details in a way that's elegant enough that it doesn't distract from it. And this is a sort of slightly enlarged detail, and you can start to see how we solved that. There's which I'm going to come onto a diagram which illustrates how that happens, but essentially we need to figure out a way in supporting those tubes above the aperture at the same time without putting in a significant frame that took away from what the glass generally was trying to achieve in terms of light and purity and clarity and minimal design. Now in Hong Kong, from an engineering perspective, we have significant challenges. There are significant wind loads. It's typhoons in certain times of the year can generate very high pressures, and the code loads associated with that, and even those coming from wind tunnel tests, are significantly higher than other parts of the world. For example, than perhaps we're used to in Europe. For example, we might be designing this facade to 1 to 1.5 kPa in Europe, whereas we're looking at designing in areas of it up to 5 kPa. So 4 to 5 times the loads that we would otherwise be seeing in more traditional facades. So that in itself is a significant challenge that we have to consider. There are other challenges that are related to the building department and the codes and how we manage to navigate those. It's always a challenge in Hong Kong. Everything has to be very much by an established code process, and it's very rigorous in terms of how we navigate that. In particular, when it comes to anything that's innovative, that's perhaps out of the ordinary, or, for example, has not been done before, precedents where there's little precedent. So, and all of the projects we've done in Hong Kong, that's been very much an important part of what we do, is to justify our designs and navigate that as successfully as we can, which I'd like to say in this instance, and this particular project was done. It wasn't easy, but it was done very successfully. So one great advantage from having the tube section is that against this wind load is that obviously the tubes have a sort of natural stiffness and inertia that allows us to get to more easily perhaps resist some of those bigger wind loads. In itself, through its very form, it has that sort of natural ability to resist load. So these and perhaps an example of why that is the case. This is quite a good slide. Not that we were considering flat glass, but if you were to take a circular tube against the 9 meter span and the loads it was picking up against a flat piece of glass, with a curved piece, you'd only have 2 times 12 millimeters annealed glass, whereas in fact with a flat piece you'd end up with 10 times that laminated together. So it just illustrates it's quite an efficient section for us to be able to resist those kind of forces. Now this is the challenge, I think, and a lot of success in terms of the detailing of it was about these openings. And what we concluded was, rather than having a significant frame or to support the tubes above the door, given the spans are quite big, I mean, talking about 10.6 meters, that even as a beam or a portal frame underneath that would be quite significant. We looked at ways of actually taking that load through rods between the glass tubes, so having a very slender steel section just as the door header, hanging that from above the glass tubes, and that spreader beam then taking all of that load that picks up the glass tubes either side of the aperture, and then putting that vertical load back down the 2 adjacent solid tubes. So by doing so, we were relieving the aperture itself from any particular heavy engineering and putting it into a place where essentially it was hidden within the building cladding above the glass tube itself. So it wasn't particularly easy to detail that, but it was in many ways one of the most beautiful parts of the facade, is how well these door frames were fabricated. They're stainless steel sections. They're relatively slender visually, but nonetheless they're reasonably solid stainless steel elements, and welding those together with the clarity and the perfection that we achieved it is very much a part of the success of this particular engineering challenge as it relates to the apertures, of course, which there are a number in a building, which allows people to get in and out. Another very important part of these glass tubes was understanding how they would perform in temperature and in light, and in particular thermal stresses. Glass, particularly annealed glass that hasn't been strengthened, has a particular propensity to be, or occasionally to suffer from what's known as thermal stress, which essentially is where a piece of glass, where glass is heated in an area where it's next to an area where it's not, so in light and shade essentially, and that differential temperature within the glass body itself can cause stresses enough to cause the glass to crack. So it's very important for us to understand that, given how much of the annealed glass we had around the perimeter, as well as the sun path and the shading, and the fact there was all the buildings around it, and therefore understanding what that is. So we did a sun path model at various times of the year, and we identified the worst point of the year where the simulation gave us the most radiance on the glass itself, as well as increased thermal light. So here you can see a slide which tries to illustrate and break down into bands where we see the most irradiance on the glass itself, where the glass is seeing the most light heating it up. At the same time, behind that is the ambient temperature of the air itself. So we look at the combination of the energy from light heating the glass locally relative to the sun angle and how that hits the glass, as well as the ambient temperature. And then we look at how that breaks down into into stresses in the glass. So this is a breakout from that. You can kind of see this A and B on the left, which illustrates, and these graphs on the right, which illustrate the difference between the irradiance in the surface of the glass, which is, there's a number of graphs here, but and because there's a number of layers of glass. But if you look at, for example, surface A, which is the big blue at the top, the curve, which gives you a certain time of day when that is maximum, and you'll note that it doesn't necessarily coincide with the maximum ambient temperature. So in many ways, one offsets the other slightly. But taking the combination of those two to get as our worst case combinations of stresses, we can plot a gradient of that temperature across the depth, across the height of the glass tube or the glass panel, and we can then map onto that the ambient temperatures, and from that, through our software, finite element software, we can establish what the maximum stresses are. And in fact, you can see on the right hand side, we have a peak stress in the corner of the panel in this instance, which in this instance, in terms of where we were looking at it, was below what would be an acceptable peak stress for annealed glass. So that process was very important in understanding how the glass would perform against heat. Similarly, the cross-section of the glass itself. So we were looking on the surface of the glass prior to that, but understanding through the depth of the glass how those stresses would build up relative to temperature. Beyond the sort of engineering of load, engineering of temperature, we have the, you know, the critical part of glass is always how you then connect that glass to either each other, or in this instance, well, to each other, often when it's transferring load between elements of glass, but in this instance, how that load is transferred from the glass into the building. And therefore the detailing at the head, detailing at the base, in fact, detailing generally is super critical and something that we spend most of our time focused on ensuring we get right. It's not only just a case of getting it to perform right, it obviously has to marry with the visual identity of what you're trying to achieve, which is why, for example, in the case of the portal frames, we went to such lengths to be able to do so. So this detail was kind of super important for a number of reasons. It allowed us to join the two tubes together, and where we did have solid tubes, we needed to have thermal performance through them. And so this detail is the how we join, shows the cassettes that are bonded to the glass and how those cassettes in turn are thermally broken between each layer, and also gives us an idea of where, well, gives us the opportunity to be able to house what's very important, which is the lighting, which sits between all of these tubes and highlights this element, which we'll see in some of the photographs at the end, are super important to highlight what this is and to distribute light through it. But this kind of junction between the two was a very pivotal detail to get correct. And just to touch upon, you know, you might have been questioning yourself as to, well, once you've got these big tubes, which are actually 900 or so in diameter, it's not very easy to get in a 900 millimeter diameter tube and service it. So we had to find a way in which we could seal it, a little bit like in an insulated unit, but seal it to the extent that it would not need ever any maintenance from within it. So actually we drew upon the ideas of closed cavity facades, and Seele looked very hard at ways in which they could take that technology, adapt it for these tubes such that a slight overpressure of air is pumped within these tubes, and that slight overpressure not only keeps any air pressure from the outside from coming in, and therefore any contaminants and dust, etc., from coming in, but also keeps this very small trickle of air flowing through it. So, and that air is dehumidified and it is cleaned prior to the point that it goes in. So everything within that space maintains a completely maintenance-free internal space within the tube itself. So here's some images of the mock-ups, which were very successful. We were looking at the whole tubes. We were looking at some of the half tubes and the cladding, or the where the half tubes were covering opaque portions, for example, walls, etc. Because remember, this facade not only wraps the building, but inevitably it covers areas where there isn't transparency. So it had to be adaptable for different typologies behind the glass tubes, as well as only just clear areas.
Mm-hmm. If I may, can I ask Jeff, because obviously there's been a sort of journey into the unknown here. You know, we're looking at lots of different options to make the project happen, and this seems to be an obvious point where you think, okay, good, it's going to happen. Did you always were you always confident that the project could be realized?
To tell you the truth, I don't. All right. Not until I see the mock-up in Precursor Factory, and after all the BD approval has been sought. I think James was right. Hong Kong, I think the buildings department in Hong Kong are rather stringent, especially in accepting innovative and new designs.
Mm-hmm.
So I think the first part is, oh, can we actually do it? So when I see the mock-up, the one full tube mock-up in Precursor Factory, I'm confident technically we can do that. And only after the BD approval and consent that was being sought, then I'm sure that this can be done. Of course, I understand there will be other challenges as well, but these two are the main concern I have at the very, very beginning of the project.
Thank you.
Yeah, I mean, to share Jeff's nervousness, I too, but I obviously didn't want to transfer that nervousness at the time. But yay. But the skill obviously is to hide that as best as you can and give everybody around you the confidence that you can, that it'll work.
I know.
But you know, we had a great team throughout the organization, as I touched upon before at the very beginning, and that's without a doubt how it happens. And Precursor and Seele really pulled out all the stops to be able to prove their excellence as contractors and fabricators to create these things, as well as many things supporting it and continue to support it. So some images of the mock-up, which went very well in Germany, and then of course some images of the construction. It was never going to be a very easy site. I mean, I remember visiting site all the time. It was, you know, this wasn't being built in isolation. There was an enormous development happening in the hotel, the adjacencies, many different construction elements all over the place. So knitting this delicate glass facade in amongst the myriad of construction typology and activities was a heroic effort from New World and from the construction team to manage. Just quite amazing. So you see some of these images of these glass tubes flying over Hong Kong Harbour and being installed into onto the facade itself, which were, and the sort of external cranes to pick them up and the manipulation of it. I mean, really quite amazing to see through construction, and then also making sure that all of the other things going on around it didn't jeopardize the fragility of these particular tubes, because they weren't at all in any way isolated at that point. It wasn't, as you say, a totally simple or clean site in which everybody had the freedom to do this particular part. So it wasn't easy, but it got there in the end, and the team did a great job in building it and finishing the building. And there's just some images of how that came to pass. I mean, it's still in its it was finished some time ago, so it's taken a while to finish the rest of the development and also to program the space, etc. So but it's certainly open now. And here's one of these images of how the door frames, etc. I was referring to integrate with the facade itself, how the finishing of the tubes and the transparency of that, and I think how they start to be occupied even themselves, as with people and plants and seating and the like. It starts to become a part of the facade, starts to become a part of the space as much as it is the envelope. And just to finish off, and there was a few other little bits and pieces which were part of the development which we were able to be a part of: the trellises, the enclosures, and the pavilion to the entrance, which is again actually quite significantly tall pieces of glass fins, etc. Again, you know, complex to get approval with, parts of the Avenue of the Stars. So there's lots of little signature elements that we worked with New World in developing, not just in the glass but throughout the development, which we're very proud of and very happy to have been a part of realizing. So beyond that, a little bit of fun. We'd like to take any project we have as being an incubator for ideas, I think, probably the best way of putting it. And so with that, this particular that was built prior to the K11 finishing, we took some of the tubes that were being made, and Precursor were interested in demonstrating their fabrication skill through Glass Tech, which is a European glass fabrication show in Düsseldorf every other year. And they just, with them, we worked on developing this slide, which not only showcased the quality of the tubes, but also was showcasing the quality of some of the fabrication and transparent connections. And in fact, it was the transparent connections between the glass horizontal rungs and the glass itself that we're quite interested in showcasing. And some of that work I've continued to take on through my work at TU Delft within our research group there. So it always has, you know, I like to think that one project leads to inform the next, and, you know, these ideas become increasingly sort of proliferated within whatever industry it is, in particular this case of glass. And that's progress, and that's how innovation grows. So I think this is our last slide, just to leave you with that image of the final avenue to Hong Kong from that first rendering I showed you in its remarkable similarity. So I think a successful project outcome for all.
Thank you. Thank you, James. Thank you, Jeff. I've got a couple of questions for Jeff, and it's great that Jeff is here because he can offer his sort of client perspective. And obviously this project is innovative, and Calvin, your colleague, has mentioned in the chat, it's really a challenging and memorable project for all of us at New World. Okay, so I mean, my question to you is, how do you as a client make the decision to go ahead with a project that requires innovation and stepping into the unknown?
Well, actually, there are two reasons for that. I think Victoria Dockside and all its components that I have talked about focused on innovation, and this is also the motto of our company in all of our projects. Not only in Victoria Dockside, but even in our residential projects, office projects, etc., elsewhere in Hong Kong and in China. But of course, the extent will not be as extensive as what you are seeing in Victoria Dockside, because Victoria Dockside is our flagship. Mm-hmm. So when Zoyle and when James came up with an innovative design, we actually like it a lot. Of course, we worry about the money, we worry about the technical difficulties, but after all of the coordinations and all these reassurances that James seems to have gave us at that time, we decided to go ahead. But I must say, the tubes are not cheap. But so at the end of the day, we have to go through a lot of value engineering in order to make the whole thing happen. Despite we actually love the innovative ideas that these guys have.
Thank you, Jeff. And I suppose the other part to the question is, when you do sign off on an innovative design, is there any way you can measure the success of its outcome? You know, has it been a success?
I think okay. When we opened K11 Musea a year ago, we are not ready to open this floor yet because we are still planning the program inside and what to exhibit at this level. But I think this was open about August, September last year. The result and the remarks given by the visitors are very, very positive. They like what they saw. I mean, it is actually fun to actually walk in the by the glass tube on the 6th floor along the visual corridor like this, and appreciate the slight diffraction and the refractiveness of the glass tube along you. This is a very, very immersive experience, I think, in terms of architectural design and engineering as well. So I think based on that, we must say this is a very successful installation or design that we have for Victoria Dockside.
Thank you, Jeff. So we've got some questions, and James has started to answer a few of them already. There is one question from Dora, and I suppose let's paraphrase the question, and it's for Jeff. Is the form of the tubes and the purpose of the space as an art event space, and also how does art and this innovative facade and K11 and New World, how does that tie together?
For me, right? Okay. Actually, the idea of having a gallery or museum quality exhibition space came, I think, in the midway of the project. By that time, basically KPF has completed all of the facade design already. But we decided to put a gallery and exhibition space on this level, and to make use of the visual corridor as an exhibition area. And at that time, we decided to look for something that is artsy, something that is special, something that people are not easily seen in other parts of the world. So KPF introduces soil to us. And soil came up, if I remember correctly, soil came up with two options, but we picked the glass tube options because it's so different and beautiful. Just based on the model they gave us.
Yeah. So I think James is just picking out some questions right now, but I've got a question for both of you, and it's about how innovation is initiated in projects. Obviously, there's innovation done by consultants, like research, ultimately resulting in innovation. Suppliers do the same as well, but in many cases, the model of innovation is client initiated. So the question I have to both of you is this the right way, and do we have the balance correct at the moment? Maybe James can offer his thoughts first.
In what form, Yachi?
Should it be on clients to be the initiator of innovative solutions? Should they be the sponsors of innovative solutions?
Yeah, and I think from our experience, I mean, it's a partnership, right? You need patrons in many ways, and I refer to that word often because you can have a client that has a very just economic outcome, but if you're going to be working on a project where there's an element of unknown, you don't know how it's going to play out, you very much need a supporting client and a supporting patron that's going to hold your hand along the way and is prepared to support the endeavor that may or may not work. And it's a brave place to be. And it's not often that clients have necessarily got that vision because they're looking to offset responsibility and liability wherever they can for obvious reasons, economically. So it does take a brave and visionary client through leadership to get there. I mean, I always say the same thing. Innovation and good engineering will always get you to the answer. It just needs to be believed in, and you've got to go through the process. It's not necessarily a case of just accepting that, okay, it's been done already over there, then it's easy, I can understand it and how it pastes into my building. But when it's not been done before, it doesn't mean it can't. Of course it can. It just needs a certain level of belief that you only know a little bit more each step of the way, and the big guy at the top's got to be prepared to accept that, and the sort of the roundabout U-turns you have to make along the way, possibly, in order to get there.
And what's your view, Jeff?
Well, I think I talked about earlier is I think for all of our project, we expect something different from the designer, from the architect, and from the engineers. And this, the glass tube facade is only one of those many innovations that we have in Victoria Dockside. Actually, in Victoria Dockside, we have 100 creative powers, which James is one of them. And I think all along the project, but the glass tube, I must say, is the boldest, is the most prominent innovation that we have in Victoria Dockside for sure. We have other innovative ideas by other designers, by other engineers and architects elsewhere inside Victoria Dockside. Even in the interior, we have 100 design modules, which eventually we obtain copyright or patent. So innovation is running inside the blood of the world of all the we call artisans in our company, and that is what we expect from the architect, from the engineer, and from the designers as well.
Great, thank you so much.
Having said that, I'm not saying we have unlimited budget to realize James' design. I think if James can still remember, we went through a lot of value engineering exercises to make this come true.
Yeah, you look at it, and of course, there's often with our projects, it's considered it's considered that we don't have a budget. But I think what people need to remember is that we're value engineering experts, because everything we look at has a very high budget and has to come down in budget. So everything has to have a very rigorous sort of value engineering exercise through it in order to make it possible. None of the work we work on isn't subjected to that. Everybody goes through that, but when you get to, when it gets to this level, you've got to be pretty creative also in the value engineering area as much as you have in the engineering end. So yeah, we're proud that we're determined to get the project built, and we're determined to make the compromises where we need to in order to make sure that it gets done. And that's as equal determination as it is to get the thing through building department or built. So, without that, we don't have a project, and that's of no use to anybody. So, that's important to us.
Yeah, because the result came out so good, a lot of people thought we'll flow in unlimited budget for the facade, for all design, but actually we have a query type budget as well. But luckily, with you guys and with Soil, who are willing to actually work together to come up with something that is buildable without sacrificing the design and the beauty of the design. I think that's very important. The teamwork is very important.
Yes, absolutely. Great. I think on that note, I think we should end. So I mean, it's coming to evening in Hong Kong and Asia, and in Europe, you've got the rest of the day ahead of you. So we'll say thank you so much to our guest of honor, Jeff. Thank you for joining us.
Thank you,
James. Thank you.
Thank you, Jeff. Great to see you again.
Yeah, good to see you again.
I look forward to seeing the finished project. I haven't even seen it since it's been finished. I've been stuck here, so.
21 days. You just need to call it in 21 days.
So unfortunately, we've run out of time. So thank you everyone for joining us. Just a quick plug for our next webinar in our series, which is Iona Sky Dome, opening up the night sky. So it's a grid shell skylight, but with a twist. It's on a cruise ship, and it's the largest of its kind out at sea, and it's in 2 weeks' time. I won't be guest hosting. I'm a one-time guest host, but thank you so much for having me. So for now, thank you again to Jeff and James.
Yeah, I think James, I think James, when you actually make your way to Hong Kong, I think we should do a tour together.
Absolutely.
With, on this level, so you could explain each and every detail to the visitors for that one. Okay. And maybe you should.
Let's do that. Let's arrange that. Yeah,
let's arrange that.
Great. Okay. Well, let's say goodbye. So thank you very much. Okay, goodbye. Joy Keen. Bye-bye.
Bye-bye.
See you, everyone.
Thank you. Bye-bye.
Bye.